All right, I think we're ready to get started today. Welcome everyone to our third in a series of webinars on Send. We're excited and thankful to have you online today. Today's webinar will focus on using Xbiom for repository functionality and cross-study analysis. Please send in your questions to our moderators. We will be posting the questions and answers early next week, along with the recording of this webinar. Cross was founded in 1999 and has served the life sciences industry since 2009. We participate with CDISC views and within industry conversation with the FDA regularly, including as a contracting partner with the FDA. The Xbiome technology platform, which we will be using today, serves as a base for non-clinical, clinical data, and metadata repositories, regulatory submission workflows, and an analysis, data visualization, and data validation platform. Large sponsors and small biotechs alike have entrusted PointCross with their non-clinical studies and clinical information, with almost 10,000 studies processed. Some of our Send services for the non-clinical side of industry include Send generation, 100% QC of Send datasets, interim study monitoring, and study data repositories. If you would like more information on these services, please visit our website, where you can also find our automatic Send quote generator. Our first webinar in this series was on common Send generation issues and how they are corrected. Our second webinar was on how we visualize Send datasets for QC and analysis. And this is the conclusion to the series. You can find links to the recordings of our last two webinars on our website, as well as the questions and answers from those last two sessions. Today, as I mentioned, we will be looking at how Xbiome can help you create a repository and how you can use it for cross-study analysis. Xbiome is a 21 CFR Part 11 compliant and validated system. Xbiome is backed by AWS and is entirely web-based for any end user. For security purposes, the system includes user-based role access, which can be edited by an internal IT team. The Xbiome platform is highly customizable, including templates and options to collaborate with teammates on visualizations. All of our Send customers do receive Xbiome access for each deliverable for visualization and QC checks at no additional charge. And all visualizations shown today can be exported. Tables can be exported into files such as Excel or CSV, images into JPEG or PDF, and any export can be added directly into a PowerPoint for your organization's internal presentation needs. Today, we will cover how Xbiome can help organizations create a warehouse for studies, non-clinical or clinical, in progress, completed, and for legacy studies. We will show how this repository can be used to analyze multiple studies at one time. We can show analysis with historical control across the same compound and across multiple classes. Today, I'm going to start with the need for a repository and what the Xbiome system can provide for your organization's needs. As a background, Xbiome can be used for both non-clinical and clinical studies. It is available as a SaaS subscription. The repository that Xbiome creates is not limited to Send datasets, but can contain any type of electronic data. This will include, but is not limited to, the Send datasets, study reports, tables and figures, and raw data. A repository of all of these files includes ingesting non-standard data, whether it be information that is out of scope of Send or the metadata surrounding the collection of the data. With Xbiome, every piece of information has a place. Datasets are linked to operate with each other, study reports are used as references, and each piece of information has a source that can be accessed within moments. The repository then incorporates the FAIR principles. Data is findable, accessible, interoperable, and reusable. With this upload, it doesn't matter if you have a programming staff, SAS viewer, or other resources you might have thought were necessary. All of your data can be accessed through this repository and visualized in this one program. Your send dataset is integrated into both an XBT reader and a visualization system. Your report is a single click away for your reference, and all of your TFLs for your report or internal reporting needs are pre-templated for you with the ability to auto-update if you ever receive new data. As we've taken a look at what a repository can handle, let's look at what the Xbiome repository actually looks like and how you can use it for analysis. Please give me one moment while switching screens. Okay, we should be able to see the Xbiome system now. And I'm going to open the SDIS, which is the Study Data Integration System. And this serves as our repository. To demonstrate the first principle in FAIR, we're going to look at the term findable. In this case, all of our data is permanently attached to this repository. Each piece that we're looking at is going to be individually assigned a study identifier. So in this case, it's on the left-hand side. The pieces of the information that were fed into the study can be individually identified as well. So, for example, if you have a LIMS extract or an Excel file, the files are labeled with the study identifier, the type of data that is contained, like weights or clinical observations, and possibly the date that the data was created or observed. This information is classified into our repository and sorted into the metadata and alternate data labeled across the top. So information is then collected on, for example, the sponsor identifiers, the compound names, the species and strain that are included within the study stage, whether it's a final or interim, etc., including things such as how many groups and how many subjects are there as well. With this data being easily accessible, I can search across my studies for an individual study or multiple for comparison. So I'm going to switch into my search criteria. Within this repository, we can search across multiple parameters. In a very broad aspect, we can look for the compound or the trial design, and those are on the left-hand side. If I were to go narrower, I can look at information such as the sex of participants. If I wanted to include only studies that included females, as many studies are done in males only. And in the most narrow sense, we can search for clinical parameters that were collected. If we were specifically looking for studies that included collection of inflammatory markers or specific biomarkers, we can do this here. Search criteria can be edited to include and/or logic and can also be saved for future references. So at first, I'm going to look at the compound ID, and I'm going to look for studies involving that. In this demonstration business space, I do have 29 studies loaded in here, and I'm going to look for a specific compound identifier. And now that they've loaded, I'm going to click PC drug 1234. And I see as I've clicked that, I go from the 29 studies that were there previously, and it's dropped down to just 7 match studies. And then I'm going to search to see which studies actually come up. From here, we can select studies to visualize together, and I'm going to select PC 202002 and PC 201909. And I'm going to take a look at these using the search for the cross-study viewer and take a look and see that everything matches up. So between the two studies, in one of the studies, I have a 13-week repeat dose toxicity study, and the other one is a 4-week repeat dose toxicity study with a 4-week recovery period. But both of these studies are done in a parallel design. They're both dosed via oral gavage, and they are both treated with the same test compound. Most importantly, these studies are both performed in the same strain of rat. I'm going to go back to my search criteria, and while this is still open, I can click the Open Documents. And once those are checked and I have the documents open, I can see that only 57 files loaded, and they all have the study identifier of one of the 2 studies that we chose. So without searching my entire documents folder, my repository has narrowed down the documents that were linked to these 2 studies. And in this case, we just have the send datasets and example study reports for these 2 studies. So now I'm going to open these in the IGO. It's going to take a moment, but as I'm opening it, the 2 studies are in this interactive graphical interface. As I've previously mentioned, everything shown today is live and web-based. This is a real loading time, and despite having this information in the back end, these buckets of information, it does interact pretty quickly. But if there is a moment of loading, it's because it is loading these 2 studies live. So I'm going to click on the body weights and look at these 2 studies together. Similar to our last webinar, I'm going to begin with the body weights. I can compare the body weights across the study, and looking at day 1, the mean of the male rat in this study on the left side is about 265 grams. And then looking at day 1 of the male rats on the right study, which is the 201909 study, the mean of the rats on day 1 is about 332 grams. So this difference right now can be explained by numerous situations. They could be different ages at the start of the study. They could come from different suppliers. And we're going to need to keep this in mind as we're evaluating the different body weights across the course of the study. But we can use this information presented to evaluate the different dose levels. Though we didn't perform these studies at the same time, we can use this information. There's plenty of similarities that we can help narrow down what might be an appropriate dose level if we were looking for where an appropriate toxicity level is. So if I'm looking at both studies, it appears that doses over 20 milligram per kilogram seem to cause a decrease or a lesser slope of body weight gain over the course of time. So if I were to look at these, I'm looking at the green in both situations is a control. These are the control subjects on there. If I select the 25 and 65, I see that there is a dramatic drop around day 15, but then they continue to gain body weight. And if I were to look at the other study, the 200 versus the 20 is still maintaining weight over time, but the 200 milligram per kilogram is very slow to start gaining weight over time. So during this, we can see this line here. There's a large gap between those dose levels, and the same with the other study. There is a large gap between anything over 20 milligram per kilogram. So while looking at these 2, I'm going to keep in mind that 20 milligrams, somewhere between 20 and 25, there seems to be a difference. I'm going to load some of the laboratory tests. Okay. And now I just have the males in each study for the clinical chemistry are presented. I'm going to scroll down to glucose. And I'm going to note here that the control in the left side of the study seems to maintain about the same glucose levels. The dose groups of 10 and 25 milligram per kilogram seem to be about the same, but the dose of 65 milligram per kilogram has decreased. Now, after the 4-week recovery period, this seems to have rebounded. We went from day 30 to day 58. There was a rebound in this glucose level across subjects. But I'm looking over at the 2019-09 study, which is dosed over time. We don't see sacrifices and blood collections until day 92, and the glucose seems to have been maintained over the course of time, but at a lower level. So we have two studies here that we've looked at, just two very basic parameters. We have the option to look at any other parameters here, add in parameters, take some of them out. We can do cross-domain analysis as well, but we can also add additional studies here. So I'm going to go to add a study, and I'm going to go to search. So the search results are currently only the two studies that I had selected. So let's say that we found something in the laboratory test results. We found that bilirubin levels were increased with the dose levels, and we wanted to see if any of our other compounds in our repository or studies with the same compounds had the same results. And I'm going to look specifically, I would like only the same strain of rat. So I'll select Sprague-Dawley there, and then go into the clinical parameters. And I'm going to select laboratory test results, and I only want to see bilirubin. So this is going to give us the entire range of bilirubin across Sprague-Dawley rats in our repository. Right now, we are seeing the percent change from the group mean displayed on the right, and we can also change that to the absolute value. I don't happen to know the historical reference range for bilirubin for rats off the top of my head, so I'm going to stick with the percent change at this point. There's a pretty wide range of results, anywhere from -60 to 400% plus the group mean. And I've decided that anywhere within 100% of the group mean is acceptable. So I'm going to look for specific outliers, and I'm going to look at any subjects that have greater than 100% change of the bilirubin up to the maximum. We're not going to change that, and that's at 414%. And then I'm going to click search. And I see that there were two studies that matched my search parameters, in that they're both the Sprague-Dawley rats and that they have that greater change from the group mean in the bilirubin. I scroll to the right and I see that there's a second study that did match 48 of the 216 subjects were found to be within that range. Now, this study is actually just a second version of one of the ones that we looked at. This is an interim version of that final data set. So we're going to move on. And I'm going to go back to that body weight that we had looked at earlier. One of the things that I'm interested in after looking at these two studies is I'm going to define my own cohorts. So I'm going to click cohort. And I mentioned that anything that was over 20 milligrams per kilogram seems to be having a lower body weight gain. So what I can do is I can now combine some of these groups. I'm going to choose, the control is going to stay as is, but I would like to choose that the 200 milligram per kilogram and the 25 and 65, I'm going to make them their own group. And I'm going to call this above level of interest. and I'm going to merge those. Then I'm going to take the 10 milligram per kilogram and from one study and the 20 and 2 from another study, and I'm going to call these below level of interest. And now I accidentally forgot from there, below level of interest. So I now have, oh, I did that incorrectly. But I can combine those and I can save them and then select that cohort. So I'm actually going to do a little bit of a switch on the cohorts. I'm going to look at the dose instead of the groups. This is now ignoring the TK. With those custom cohorts, I would be able to see if there's some cleaner lines with instances of clinical observations or the macroscopic or microscopic observations. It's not the most perfect example, but I hope it gives you an idea of the options that Xbiom can provide with customizations. And I'm going to show another example. I'm going to choose a different 2 studies. So I'm going to close everything that I had opened out, and I'm going to go into the SDIS again. And I'd like to take a look at the monkey studies. And I'm going to choose this PCSA study and webinar 001. So as of writing this, I can see already that they don't have the same test compound. But I'm going to take a look at this cross-study viewer again. In the webinar study on the left-hand side, it's a 4-week repeat dose study in monkeys. The test compound is AMED. It's a completely fabricated test compound. It is a parallel study. This is done by intravenous infusion, and the subjects are 2 to 3 years old. And this is also, I believe yes, the dose is 1 time per week. On the right-hand side, this is actually a 39-week study. This is a 39-week study by oral gavage with a different compound number, again, completely fabricated. So we've said that the route of administration is different. Actually, their ages are different. The study on the left-hand side is 2 to 3 years, while the study on the right is about 2.5 to 5 years. And we said it was done by oral gavage. And this one is actually dosed daily. So we can pretend that these are in the same class or not. These could be in different classes. But whatever it is, these 2 studies are completely unrelated. And I'm going to then visualize them together. And we'll start with body weight again. So if I take a look at the left-hand side, these are going to be the individual values. In this shorter study, subjects tend to maintain their body weight. They may fluctuate up or down like 0.1 kilo, 100 grams over the course of the study. The biggest change within here is 200 grams over the entire 4 weeks within the study. On the right-hand side, though, these control subjects, which are seen in green, seem to be gaining body weight uncontrollably compared to the other dosed subjects. Now, this could be due to numerous factors, but we also see some of these dots in red are going down at some points. So for reference, this green subject in green, over the course of about a year, it's 39 weeks plus an 8-week recovery period. This subject gains 3 kilos over the course of time. So it's gained almost 100% of its body weight. These red ones, though, are really maintaining their body weight over time. They're not really gaining, but as much as they're gaining, they're losing just as well. So we're seeing this separation in these dose groups. If we pretend that these subjects are from the same supplier, if everything were comparative in the metadata that we looked at earlier, we might be able to say that there is something going on with the test article in this case. In this study on the right-hand side, these subjects are older, and there's quite a few factors that could be going in here. I'm then going to go to the organ weights. And I'm only going to load the actual organ weights and remove the females. And then I'm going to do a simple I have to do a reconfiguration very quickly. And this should be it. So on the left column, we're looking at the shorter 4-week study. On the right, in the middle and right columns, we're looking at that longer study. And the two different columns are due to the main study and the recovery period. So if I'm looking at these males, I can see actually that the adrenal gland seems to be impacted by this high dose group. This may have caused a decrease in weight from the actual subject, whereas the other drug did not. And we also see that the pituitary gland has an increased weight in some of the dose subjects. If we're looking at the other study, the monkeys that are in this other study have a higher pituitary gland weight. This is something that we can write off most of these subjects. If we look at all the organs, most of them are heavier because they are older animals. So I hope this gives you some information into how this can be used. All of these observations can additionally be performed with historical control information. With Xbiom, you can add in historical control reference ranges per species, supplier, test facility, and age, and you would be able to generate to see outliers or deviations from the standard, and what you may or may not be able to expect. So we would be able to tell which of these drugs were impactful and if the results were an impact from the drug in question or the class that's being investigated, if these were under the same. So with that, we are coming to the end of time. I'm going to leave the webinar open for a few more moments so everyone can send in their questions. Again, we will be posting the question and answers along with the webinar recording early next week. And if you have any further questions, please contact us at ask@pointcross.com. Thank you and have a great rest of your day and week.